Hi, I'm Paul Battaglia, and this is section 4.2, Trigonometric Functions, the Unit Circle. In section 4.2, perhaps the most critical thing for students to understand is the unit circle. And what better way to get them to do that than to build it, perhaps from scratch. So I'm joined by Gabe and Brittany, and we're going to walk you through how we would actually kind of take students through the process of building the coordinates that go along the unit circle right from zero, right? Okay. So let's do that. So what we'll do is we'll call on their knowledge of special right triangles from geometry. Okay. All right. And what I think is a good idea is to have your students look at a blank unit circle, preferably with perhaps some lines where 30 and 45 and 60 and those multiples would be. Mm-hmm. And that way we can kind of draw the appropriate triangles. So I think we'll start at 30. So we'll start at the 30-degree angle. And what we'll do is we'll go to the spot on the circle where the radius intersects the circle at that coordinate. And we're going to drop down a line segment to create a right angle. And so what we're in essence doing is we're creating a 30, 60, 90 triangle, and we'll label it as such. So the big question students ask is, why do they call it the unit circle? And that would be because the radius of the circle is 1 unit. So what we'll do here is we'll actually take advantage of that, and if we look carefully, the radius of this circle actually corresponds to the hypotenuse of our triangle. So we will label that 1. So now what we want to do is we want to have them call upon those relationships in the 30, 60, 90 triangle. And so what I may even do on the board is I might write down, okay, I may even write the triangle and I might say, okay, well, what do we equate this 1 to be? What do we say the hypotenuse is equal to in what expression? And we say that that's 2s, right? And that the side length is opposite 30 degrees, right? Mm-hmm. So what I would do for them is I would say, okay, well then if we know that, isn't it logical to say that 1 must equal 2s, mm-hmm. right? And I have them solve that. And so then they say, okay, well, so the side length equals 1/2. So here's the critical question. I say, well, where do I place that 1/2? Where does that 1/2 belong? Mm-hmm. And I want somebody to say, well, that would belong, in this case, opposite the 30-degree side. So we're going to do that right now. We're going to place it on that side of the triangle, call that 1/2. Then I'll say to them, all right, well, what about the remaining side? How do we find that one? And they'll say, well, the relationship or the expression for the 60-degree side would be radical 3 times s. So I'll say, all right, well, if we know s is 1/2, then we can just do radical 3 times 1/2. But it looks kind of messy. So I say, is there a better way to express that? And so, if we multiply the fraction, we say, all right, well, that's radical 3 over 2. Mm-hmm. Yeah. Perfect. Let's label the side opposite 60 degrees as radical 3 over 2. Okay, now, do you have to start like this? No. You could start with the 45-degree angles, which we'll do in a second. You could even start with the 60-degree angle first, and just put that angle in towards the origin, and that's okay. It doesn't really matter where you start. I just thought it was logical to start at the first point here. Mm-hmm. So now that they do that, here's the big question. How does it all tie in, right? Yeah. I say, well, look carefully. That coordinate, that point that we have there, that has coordinates x, y. But if you look carefully, if you look along the triangle, along the x-axis, right, it only goes so far. It actually matches up with that coordinate. So what must our x-coordinate be then? Radical 3 over 2, right? So I say, all right, let's label that. Let's actually put the coordinate radical 3 over 2 down. And then hopefully they see at this point, well, then that must mean that the y-coordinate
is 1/2.
Is 1/2. Perfect. Right? So we pause for a minute and I say, as a class, do you think that we need to draw 3 more triangles of this size? And invariably the answer is really no, because if we look carefully at the symmetry and the patterns, then that must mean that this triangle is going to occur somewhere else, right? So maybe I'll point their attention to the second or the third quadrant, or it doesn't really matter. Maybe even the fourth quadrant's a good one, and say, well, what would happen if we drew this triangle in essence upside down in the fourth quadrant? And
the y value of the point would be negative.
That's it, right. So I just want them to make that connection that all that's happening is that the value is changing from positive to negative, perhaps. That's it, right? Yep. And so I let them go around the circle now, and I have them label the coordinates of 150 degrees, 210 degrees, and then 330 degrees, consistent with this triangle that we've drawn. Okay? Cool. If I feel it's necessary, I will go through the other portion and go to the 60 degree, but I actually don't find it necessary too much because I ask them the simple leading question. I say, can you tell me what might happen if we redraw this triangle now and we just change the location of the 30 and the 60 degrees? And what do you want? You want a student to say, well, wouldn't the coordinates basically just switch? And exactly, that's right. Okay, let's go around the circle again. Okay, so then I do think I would walk them through the 45, 90 case. We don't have to do it here, but I think I would draw the 45, 90 triangle. I would get them to think about it in the same way, talk about the expressions as radical 2 and that kind of thing, bring it into it, and say, all right, let's go solve for those side lengths. Let's plot the coordinates, and let's go around the triangle, for sure. What do you guys like to tell your students or try and have them pick up on as they're doing this?
Something that I like to point out as we're working through activities like this is maybe even as we're just walking through the first quadrant, if we start at the first point on the x-axis, so where the circle intersects the x-axis, let's just look at the y values first. So the y value at that point would be 0.
Right.
Then as we go up 30 degrees, our next y value would be 1/2.
Okay.
As we go up to 45 degrees, the y value would be square root of 2 divided by 2, square root of 3 divided by 2, and then finally 1.
Right, okay.
And that's something that I'm sort of pointing out to my students. The y values are increasing as the angle increases, but then once you get past 90 degrees, your y values start decreasing.
Okay.
And I can have a similar conversation about the x values of each of these points.
Brittany, how about you? What do you like students to see as they're building this here?
I like them to see that the x value ranges from 1 to -1, and same with the y values.
Good.
That way we can get into discussions of domain and range.
Love it. And we can also talk to them about how once we get past 360, it doesn't stop there. So if we were to have to evaluate some type of an angle bigger than 365, 40, or whatever might have you, then we can still kind of introduce, or at least tease the idea of a periodic function.
Yeah. And there's nothing stopping us from starting at 0 degrees and moving
and
down
going
45
that
degrees.
negative angle, right? And I think that these are all great points that you're going to want to bring up with your student for sure. I think one of the other things we're going to have to do now is define the 6 trigonometric functions, right? So we do that with them, we walk them through it, and then we actually might even say, get into it a little bit in the next section. I don't want to go too far, but we'll get into the right triangle idea of opposite and hypotenuse and that kind of thing.
And that's something they may have already seen in geometry also.
Right, and so we're hopefully calling on prior knowledge, and just kind of dusting it off a little bit. I think the one thing we want to leave them with, though, is the idea of which one of these coordinates is cosine and which one's sine. Right, and now, Brittany, you have a good way of helping students remember that, right?
Yeah, so thinking about the alphabet, sine starts with an S, and cosine starts with a C.
Right.
So, and X goes before Y, C goes before S.
So that's it. Just stay with the alphabet, and you're going to be fine. Right, exactly. I think there's a lot you can do with this section. You can get into even and odd properties or other things you can talk about. But I think if students have a very solid foundation with the unit circle, that's going to set them up for much success later on, especially if you're talking about angles that aren't common and aren't on the unit circle, right? I mean, 87 degrees is out there, right? I mean,
that's another thing you don't want students to get confused about and think, oh, here's a unit circle, now how do I find sine of 87 degrees? Oh, wait, it doesn't exist.
It's not there.
It's
There's no value, right? Or even the idea that all the functions are defined at every value, right? I mean, I find sometimes what gets lost in classes, so we have all these triangles and stuff, but what about just something simple like 90 degrees? So we didn't draw a triangle there. How do you define? But Brittany, like you said before, I want them to be able to look at that and say, oh, okay, well, so cosine of 90, that's the x-coordinate, that's 0. And I think if we put all that together, it really sets them up for success.
Yes.
So I hope these tips have been helpful for you and that you find much success in section 4.2.